Hey everybody, I hope you're having an awesome Halloween. Let's get into our math lesson. I really like this particular lesson. I think the math in it's really interesting. And in this one we are going to be solving equations with a common base. Now, before you can do this lesson, you need to have some of your common base, like you need to have some of your exponents up in your head. Like you need to know that 3 squared equals 9. You need to know that 3 to the 4 equals 81. You need to know that 3 to the negative 4 equals 1 over 81. Things like that. You want to have your exponents down. I did mention in class which exponents you need to have memorized, and all of these are definitely on the list. So, in this one, let's start with 6 to the x minus 9 equals 6 to the 4x. Well, this is just the basic intro. Because we have the same common base, that if the base is congruent, that means that their exponents must also be congruent, or equivalent. That's probably a better word, because this is not geometry, it's algebra. But if the bases are equivalent, their exponents are equivalent, so we set the two equal to each other, and then we just solve the equation as we normally would. You get negative 9 equals 3x, which means x equals negative 3. All right. Now that's the only example I have today where the bases will actually be the same. Example 2, and actually this just reminded me. Let me quickly show you. I have 7 examples planned today. These are those 7 examples. Make sure that you either do these examples with me, before me, or after me, but make sure that you can do these 7 examples before you come into class on Tuesday. All right, back to it. Number 2, let's say I had 6 to the x minus 9 equals 36 to the 2x plus 3. Well, these two sides, they do not have the same base, but they have a similar base. I know that 6 squared is 36, so on this side I'm going to change my 36 to a 6 squared. Now this 6 squared is being raised to the exponent of 2x plus 3, and then if we apply the power rule to this, we have to kind of distribute. We're multiplying the 2x plus 3 times the 2, and that becomes 4x plus 6. So I have 6 to the 4x plus 6 equals 6 to the x minus 9. Now the bases are the same. And now that the bases are the same, I can just simply set the exponents equal to each other. Add 9 to both sides, which would give me a 15 over here. Subtract 4x from both sides, gives me a negative 3x over here. Divide, and you get x equals negative 5. All right, same base. Number 3. Example 2 and 3 are actually quite similar. I'm gonna switch 3 around. What if I had 64 to the 2x plus 3 equals 4 to the 3x? Well, what do 4 and 64 have in common? You need to have those exponents in your head completely locked down. I know that 4 to the 3rd power, 4 times 4 times 4, that happens to be 64. Whoop, not 4 to the 4, 4 to the 3. So if I go 4 to the 3rd power raised to the 2x plus 3, on my next step I need to multiply my 3 times the 2x plus 3, and I end up getting 4 to the 6x plus 9. That must be equal to 4 to the 3x. And now that we have the same base, you can set it all equal to each other. 6x minus 9 equals 3x. Subtract 3x from both. No, I'm going to do it the other way. I'm going to keep the negative 9 here, bring the 6x over to give me a negative 3x, which means x equals 3. My next example, example 4, is actually a lot like numbers 2 and 3, so I'm really going to rush through this one, not even talk about it really. Oh no, I do need to, because this one I have to do stuff to both sides. Never mind, this is a good example. let's say 27 to the 4x minus 1. All right, when I think about the smaller number 9, I cannot raise 9 to an exponent to get to 27. So what do these two have in common? You need to have those exponents up in your head. I know that 3 squared is equal to 9, and 3 cubed is equal to 27. So to both sides, I change the 9 to a 3 squared. I change the 27 to a 3 cubed. And now I distribute, so I have to do this stuff on both sides. 2 times 5x is 10x. Over here, 3 times 4x is 12x, and 3 times -1 is -3. And now that the bases are equivalent, now you can set the two sides equal to each other. 10x equals 12x minus 3. That means -2x equals -3, which means x equals positive 3 over 2. All right, 6 minutes in and I already have done 4 examples. I only have 3 more to go. Now all of these previous problems involve positive exponents. The rest of these problems are going to involve negative exponents. Or namely, they're going to give you fractions and you're going to have to translate those into negative exponents. Example number 5. Let's say I have 2 to the 6x equals 1 over 8. Alright, well, 1 over 8, that means a negative exponent. I know that 2 to the 3rd power equals 8. That means 2 to the -3rd power must be equal to 1 over 8. So I change this 1/8 to 2 to the -3. Now I can set the two sides equal to each other. 6x equals -3. Divide by 6. Answer is -1/2. Alright, number 6. This one's a lot like number 5, so if you understood number 5, number 6 should work out similarly. 1 over 81 to the 1 minus x equals 9 to the 3 minus 2x. Okay, so fraction. Well, let's see. 81, if I ignore the 1 over for a second. 81. I know that 9 squared equals 81, so that means that 9 to the -2 is 1 over 81. So I change my 1 over 81 to 9 to the -2 to the 1 minus x equals 9 to the 3 minus 2x. You got to distribute here, so you get 9 to the -2 plus 2x equals 9 to the 3 minus 2x. And now that the bases are equivalent, the exponents must be equivalent. So -2 plus 2x equals 3 minus 2x. And now we just solve like we normally do. Add 2x to both sides. That would give me a 4x. Sorry about that typo. Add this 2 to both sides. That would become a 5. And x ends up equaling 5/4. Alright, math students, one more example for you, and then I am done. And this problem represents as hard as they get. If you can solve this particular problem, you're probably going to be okay with these problems on any given quiz or test problem I would toss at you this year. You have a 25 on one side, a 125 on the other side. I know that 5 squared equals 25. I know that 5 cubed equals 125, which means 5 to the -3 equals 1 over 125. So I'm going to use a base of 5 because 25 and 125, that's what they have in common, a base of 5. So 25 becomes 5 squared. 1 over 125 becomes 5 to the -3. But don't forget about the exponent stuff. This is still being raised to the x. This is being raised to the 4 minus 6x. Distribute this exponent, so this becomes 5 to the 2x. equals 5 to the negative 12 plus 18x. The bases are equivalent. That means the exponents must be equivalent, which means that 2x equals negative 12 plus 18x, which means negative 16x equals negative 12, which means x equals negative 12 over negative 16. Negative divided by negative is a positive, and out of both of those you can divide out a 3. No, out of both of those you can divide out a 4. 12 divided by 4 is 3, and 16 divided by 4 is 4. So you end up getting positive 3 over your 4 is over your answer. All right, everybody. That is solving exponents using a common base. I don't want to throw any extra problems at you right now because these were 7 solid examples. And if you can do these 7 examples, I guarantee you're going to be able to do great on our on the worksheet that I'll have for you on Tuesday. So with that, have yourselves a wonderful weekend, a wonderful evening, a wonderful Halloween, whenever it is that you're watching it. If you're watching this in class, okay, I'm glad you're watching it, but you should have watched this at home last night. Have yourselves a great day, and I'll talk to you soon. Bye-bye, everybody. Stop.